This episode is brought to you by Ardan Labs Education. Sign up today to learn advanced concepts in Go, Docker, Kubernetes, Terraform, and more. Visit ardanlabs.com/education for more information.
Welcome to the Ardan Labs podcast. Our special guest today is Damian Gryski. Dude, I cannot believe that I'm seeing you again. I mean, I guess I could have seen you, but dude, it's so nice to see your smiling face.
It has been ages. I think the last time I saw you possibly was in Amsterdam. You came for like a training.
Dude, that was forever ago, man. That means you were still at booking.com or something.
Yeah. So at least I've now been 5 years at Fastly. So that was probably the last time I saw you in person, unless we met up at a GopherCon.
Whoa, we got a lot to talk about here. Oh my goodness. Okay. So for people who don't, though they should necessarily know who you are, why don't you give everybody like a 2-minute spiel on like what you're doing today?
2 minute spiel. So today, I work for Fastly. We're a CDN. I am working on TinyGo support for our Computed Edge product, which is a WebAssembly-based edge computing platform. Prior to that, I was doing distributed systems at Fastly, and prior to that, I was doing distributed systems for Booking.com. I've been using Go. I think I've been using Go for a little bit more than 10 years, and I think I've been being paid to use Go for about 8 years. So I've been doing this a long time, which is kind of entertaining because it means that I've seen a lot of changes, and just makes it more exciting. And I'm still excited to use Go and play with it and continue to use it for work and my personal things that I build. So.
Well, I've never forgotten you working at Booking and that being a Perl shop and you finding ways to kind of get Go in your life over there. Like that's always stuck with me, because I didn't realize at the time I met you that you weren't doing Go full-time dev because of everything you were contributing back into the community. It was mind-blowing to me.
Yeah, it was that was an interesting period. Uh, I think it's like how do you introduce a new technology into a company, like trying to find ways where the existing technology really is not appropriate anymore, and trying to convince people that the workarounds that they're using like have more downsides than simply introducing a new technology like Go. Um, and sort of working against that, but trying to do so in such a way that kind of like doesn't immediately get you fired. There's a lot of shall we say political machinations that have to go on in using social capital and all that stuff. And it was tricky. And I think the most success that I had was finding a couple places where we had tried to use Perl, and for the concurrency requirements or for the CPU requirements, it was like it was not a success. And saying,
Don't go too far deep. Don't. I'm going to interrupt you just a second because I want to get to that story. I don't want you to tell it all just yet because that's kind of near the end. But I didn't know that you were working on TinyGo, and you said Wasm. You're working on WebAssembly.
WebAssembly stuff, yeah.
Yeah, the TinyGo is generating the WebAssembly. Are you using Rust for that?
So the WebAssembly runtime that Fastly uses is called Wasm time, and it's part of the Bytecode Alliance, and we actually just hit 1.0 today. The announcement went out. Again, all the details for that and what I'm allowed to say, I will refer you to the various announcement blog posts. But Wasm time is powering our Computed Edge platform, and in order to allow people to build applications in Go that run on Computed Edge, the solution is TinyGo. And so we're using that to build the WebAssembly binaries, and then they get deployed.
That's amazing. I can't wait to get. Now I want to get to the end so I can talk to you all about that stuff, man. That is super interesting. Does Ron Evans know that you're working on any of that stuff?
Ron Evans is very much aware. I think I've been hanging out in the TinyGo channel for about the past year, contributing, bug fixes and patches and discussions and whatnot. So, and I think it's a nice little community we have there. And I mean, especially around TinyGo, there are a lot of people that are really interested in like good Wasm and WASI support for Go. And I think the main Go compiler, I think there's like an open bug report, but it's basically stalled. They're waiting for somebody from the community to step up and basically do that. I think the main Go team has said we are not interested in doing this. Um, and and because TinyGo basically gets that support for free because it uses the LLVM backend, a lot of people now are interested in using TinyGo for the Wasm, or like basically for that Wasm support. I wish there were slightly more people who are interested in like fixing TinyGo's Wasm support. It's like so there are a lot of comments and a lot of bug reports saying like TinyGo doesn't do this, and the answer is like yeah, yes, you're right, it doesn't. Could you please fix it and help us do that? Um, but I think for the most part, I think there are a small number of large bugs that are really preventing, I think, wider deployment of TinyGo, and some of those are just because it's because it is a reimplementation, and there are some parts of the standard library that we can use, and some parts that we can't. And I think the big one for us at the moment is Reflect. The so the Reflect package obviously is tied very closely into the extra meta information that the Go compiler puts into the binaries about all the types and everything, and TinyGo just doesn't do that yet. And so the two things that we have to do is first we have to get the TinyGo compiler putting in all that meta information, and then we have to write our own Reflect package that uses that meta information that has been put in. And man, Reflect shows up in a lot of places you wouldn't expect, or rather, the places you do expect. Everybody wants, JSON support, XML support, like testing support, and it's like, well, we're got it doesn't work there yet. Sorry, uh, but we're working on it.
I would think that adding that to the binaries is that like a 0.5% increase in binary size, or is it significant?
I don't know. I think there is a patch that is starting to do that. That Ica has started on. It hasn't been finished, and so I don't know the actual binary size increase. I'd have to look it up in the benchmarks attached to that PR. Um, but it is going to bloat it somewhat. And I think it's one of those things that because it is like a fundamental part of the Go compiler, at some point we're just going to have to bite the bullet and take that hit for binary size because everybody wants it. Obviously, with TinyGo versus Go, uh, we we have a much simplified runtime. We have a much smaller garbage collector. There are a lot of things that we have stripped out of the main runtime that give us binaries that are way smaller than what the upstream Go compiler produces. And for a lot of these like embedded blockchain VMs and edge computing kinds of stories like are really good because it means that you don't actually have this like massive binary that has all of your logic. You have a much smaller binary that has a higher percentage of your logic that you care about in there, and just all the processing whatnot that goes along with those smaller binaries are then better. So it's not even clear that if the upstream Go compiler all of a sudden added WASI support tomorrow, everybody would jump to it because there are still a lot of advantages that TinyGo has, and not even on the embedded space, just for Wasm and WASI in general.
All right, we're going to get back to all of that because it's fascinating to me, and I have a ton of questions, and I didn't know that you had at least a good full year of experience here. So I want to get some questions answered, but we're gonna get there.
Oh, ask away.
But this podcast is really about you and the audience kind of getting a sense of your journey through tech. So a couple things before we start. You didn't grow up in the States, right? Where did you grow up?
So I grew up in Toronto, and I had a normal Canadian upbringing, whatever that means. I think I first installed Linux in 1994 No, 1995, May of 1995. And I actually remember being on the phone, and a friend of mine was walked me through an install of Slackware over the phone uh, on my
But
computer.
how old are you in '95? Are
So in
you in?
'95, I would have been May of '95. I think I would have just turned 16. That's right. Yeah, because I had a 4 CD set of the InfoMagic CD-ROMs, and they were dated December 1994, and that's what I installed of May of '95. So yeah, I guess I would have been 16.
So you're in the equivalent in the U.S. of high school at that point.
Yeah, yeah. Grade 10, I think.
Yeah, could be 10.
Yeah,
Yeah, it
yeah.
could be
Grade
10,
grade
10.
grade 10, grade 10 or 11, somewhere in there.
Yeah, 10 grand. And why are you installing this at 16? What had popped
That
up
is a
in
good
your
question.
life?
So I, so I mean, I started programming, I think, grade 6. So I would have been, 11 or 12, in that range. Started doing basic stuff. Really enjoyed the programming aspect of it. I think in grade 9, and then did, sort of like basic and QBasic.
But where were you doing that programming at such an early age? You had a computer at home?
I had a computer at home. Yeah, I had an Intel 80, what is it, 8086, I guess, 8088. So some ancient, monochrome, uh, like amber and black screen with, the 640K RAM and a 20 meg hard drive. Um, and it was doing, GW Basic on that. Um, and I just liked it, going through the, typing out programs from the, Usborne computer book series. Um, and that was always entertaining. And then I think my mom got a new laptop in 94, maybe. And that had QBasic on it. All of a sudden, wow, this was like so much faster. It was amazing because I think that would have been a 486 laptop, which is way faster than this 8088 laptop. Or sorry, not laptop. Yeah, laptop. Um, Tower, massive tower. Um, and that had QBasic on it, which all of a sudden like opened up. Wow, like this is so much faster. Than anything that I wanted to do. And I think that at that time, I'm trying to think if I started doing, uh, like I remember doing assembly programming, like on that laptop, but it probably wasn't in QBasic. I think it was probably I must have gotten Turbo Pascal at some point. So I think even in grade 9, I knew that I really enjoyed programming, and I remember going to the math teacher because I wanted to uh, go into the like the grade 11 computer science class like my next year, even though I was only in grade 10. He's like, well, bring me something that you have written. And so I brought him a program that was actually a site swap generator. So site swaps are a mathematical juggling notation for listing out and coming up with juggling tricks. And in my youth, I was a juggler as well, and so this is one of the programs that I wrote. And he was like, looked at this, basically implementation of an algorithm. I find it amusing that even in then, that is basically something that I was doing. And so, like, yes, you can go into the grade 11 computer science course. And I actually remember that I walked out of my last exam in grade 9. And I was like, wow, I'm going to be in the grade 11 computer science course. I know they're doing Pascal, and everybody else will have done like the grade 10 computer science stuff. So I better, figure out. So so I'm not really far behind. So I went out and I bought a copy of Turbo Pascal 7. And over the summer, like I basically taught myself all of Turbo Pascal. And I remember showing up in, so like first day of classes and realizing that I had taught myself effectively the entire course that we were going to do that year. And well, I guess I kind of know this stuff then. So that was entertaining.
Okay, I want to ask you, since you're doing so much programming at home, what kind of, when I was doing all that programming at home, and it was really basic until I went to university, and I'm bad at games, but I was writing just a lot of like textual based sort of games. That's what I was spending my time doing, even though I hate gaming and I couldn't even win the games I was writing. What were you, what type of programs were you writing throughout that junior high and say high school?
I was doing some graphic. So I know I did some assembly work, but that was mostly writing a graphics library. So I'd write like the main logic in Turbo Pascal, and then like drop down into assembly for like the actual pixel drawing stuff. So I did sort of like graphics programming. I wasn't using it to write games. I was just using it to sort of like write dumb little graphics programs because I was more interested in like the algorithms and the assembly work and sort of learning that. Um, I was probably unsurprisingly writing programs to like solve quadratic equations, and writing simulators for things. I loved and worked through probably all of the example programs in a series of books by A.K. Dudney. Um, so again, I mean, I could just talk for ages and ages and ages. So once upon a time, in Scientific American, um, there was a series of articles called Mathematical Recreations. And after Mathematical Recreations, there came Computer Recreations. And this series of articles in SciAm were called Computer Recreations. They were a bunch of articles, and they were all written by A.K. Dudney. And those were then collected and published in, I think, three books. One was called The Magic Machine, one was called The Armchair Universe, and the third one was called The Tinker Toy Computer. And there was a fourth one that was called The Turing Omnibus. And so these are all basically like, here's a neat thing about computer science, and here's an article about it, and then here's like a program that kind of like uses like this idea that we were just kind of talking about. And so I was doing those. And so, I mean, that was, yeah, implementations of algorithms in math and computer science. Again, going like, going back a long time.
So what's interesting to me is none of that material ends up in my household. So how do you even know this material exists? How is it getting in front of you? Where are you finding it? Who's sharing it with you at this time?
The public library. So I, very quickly exhausted the public library resource, like in the children's section, and then I went to like the adult section, and discovered the magic of reading bibliographies and asking the librarian and getting books on hold sent from other libraries. And I was also fortunate enough to be able to get a library card for the University of Toronto Library, even though I was not yet a student there. And so I was then able to go and browse the university computer library section, and take out books when I was in high school.
So this is a lot of self-interest. This is
This is
self-discovery, self-interest.
this is entirely self-interest. And I have to give a shout out also to my high school math teacher, Miss Sellers, who entertained all of my questions and answered so many of them. Like after class, like questions about math, questions about computer science, because I think she actually had a CS degree as well. And so just being able to answer my questions and point me in places of other things to look up. And I was just devouring everything I could get my hands on, and then writing little programs to explore those things. Like I remember, like I learned complex numbers because I read an article from A.K. Dudney about how to write a Mandelbrot generator, and I'm like, wow, what's this weird thing with complex numbers? And trying to look it up, and you know, and obviously there was a little bit in the book about that, but then going to Miss Sellers, and she said, oh, complex numbers, yeah, you'll get to that in like a couple of years, and very quickly sketching out what complex numbers were, and I'd say like, thank you very much, and then I'd go back to the library and pull out a high school textbook and find, okay, where can I learn about complex numbers so that I can understand what this Mandelbrot generator thing is actually doing.
All right, I got so many questions here, but the first one is, did you at you don't have a fully mature brain yet at this time. Did you struggle with the math, or did light bulbs just happen to pop all the time for you?
I think this light bulbs went out, went up, went on. There you go. That's the preposition I'm looking for. I think I just I just understood it. I think I just gobbled up a lot of that stuff. Like, am I one of the like burnt out, formally gifted kids? Yeah, maybe. Um, like, is anybody truly really formally gifted? But I think it was something that I loved, and I just dove into, and I really. I mean, obviously there were things I mean, there were things that I didn't understand because I didn't have the math, right? Or I didn't have enough of a theoretical background. So I know that when I was in high school, one of the books that I got from the university library was a copy of the Red Dragon book, right? So the compiler's book. And I remember, reading, like trying to read it, and I could basically read, like chapter one, because where they sort of go through like a miniature stack machine, and you sort of build a tree for an expression parser, and then you spit out opcodes, just in a very straight directed walk to the graph, and you sort of evaluate it, and I could understand that. But then they get into the later chapters, and all of a sudden, you're talking about stuff with like regular expression trees and the regex to FSM, what is it, duality, whatever, and the CFGs and all the more theoretical stuff. And I'm like, I do not understand this, but I do understand chapter one. And then I remember, like first year university, I had done a little bit more of that stuff, and I actually bought a copy of the Red Dragon book, and I'm like, okay, I read chapter one. Hey, now I can understand like chapter two. This is amazing, right? And third year university, all of a sudden it's like, oh great, now I've done all of the like introduction to the theory of computation. Now I understand more about finite state machines and that work, and I understand more about CFGs and first-time automata, and I understand all that stuff. And now I can start to struggle with like how all these optimization passes are going to work. And then fourth year, I actually had a compilers course, and so I wrote a compiler. Um, but so I mean, there were some things that were like that. I would see them and maybe understand enough to get what I'm trying to do at the moment, but have in the back of my brain, okay, this area exists, and if I need it again, then I can go look it up again, and I'll have a little bit more to like to sort of get my foot in the door and squeeze out a little bit more information, from what it was that I wanted.
But you're describing my life on any white paper. I can read the introduction and maybe the next section, and I can understand the semantics, and then they start throwing math at me, and my brain just very quickly it's like, you know what, this is implementation detail, I'm done. I'll do it myself.
Yeah, and I think for me, like math, like I always loved math. Like I always loved math. And so I think, for whatever reason that clicked for me, and it translated, into the into the computer science area. And obviously I went to my university background is all.
But wait. Don't go to university yet, because what is fascinating to me is I don't know what your teachers did with you. You were ahead of every class when it was time to be in that class. You had to be way ahead of your math. By the time like, I imagine maybe you took some calculus in high school. Like, explain that situation. You must have had these teachers on the ropes.
So I did do calculus in high school, but that was because I was in Ontario at a time when we had OAC, which was effectively grade 13, and so calculus was one of those classes that I was able to take. Um, but yes, I had already seen calculus because I was looking at other things previously. What did my math teachers do with me? They humored me. They answered my questions. They gave me my A's. I mean, I remember. Again, this is one of those stories, right? Like I remember, Miss Sellers sort of, walking up the aisles, checking everybody's homework, and she sort of got to me, and it's like, have you done your homework? And like my note paper is blank, and she's like, okay, checking, you give me the check anyway, because she knows that I know whatever it was, we were doing. And it's one of those, like I was a good kid, right? Like I didn't, get in the way with my intelligence. I just, asked interesting questions that were possibly not entirely related, but not entirely unrelated. And I just it's like I did the coursework that they asked of me, and I just did like so much more on my own, to keep my brain interested and occupied. And I think that they knew that this was the case, because again, I would do whatever thing we were going up, and then I would go up and after class, and I would ask them, okay, but like three steps down the road, I'm thinking of this thing, and how does that actually work, or what does that look like?
So I want to ask you about your parents real quick, because did what did they do? Did they just talk about your parents a little bit? I don't know what question to ask, but
Yeah. So my mom, I was a children's librarian for I don't know for years and years and years. And then she became a hospital clown, uh, basically working again with the kids that she had seen as a librarian working in the hospital. Um, and then and now she makes jewelry and like basically wire work stuff. Uh, and it's amazing. And I will try to send you her Instagram so that you can link it in the show notes, however that works. um, and my dad was a lawyer, or yeah, I guess was a lawyer, retired now. And just lots of logical arguments over the dinner table. And it's like, and I mean, I don't think there was anything specific that they did, with the math sort of things. I mean, they kept me very occupied with like various Saturday morning clubs at the Royal Ontario Museum, so I would learn stuff. I did circus school, and I did juggling, and I did a lot of that stuff. And then sort of at some point I'm like, okay, but I have to get into university, and it turns out that like being a juggler is not actually a good term, like career option, a good long-term career option.
But did you enjoy the juggling? I get a sense
I
that
love the
it was
juggling.
it
Oh,
was the
I
opposite.
absolutely love juggling.
I mean, it's technical. I can juggle three balls. I've never gotten beyond three ever in my life. It's technical, right? Like, talk about the juggling because you even turned it into math.
Yeah, I love juggling. It was so much fun. I one of the one of the downsides, I think, for me of going to university is I got so caught up in university that I stopped juggling, and that was really sad for me. And I think in Montreal, I did a little bit of juggling, um, there after I graduated, and then kind of when I was in Amsterdam, it's like all of a sudden now I have kids, and I can't really get away for like a couple hours, on the weekend to go to some spot and do juggling. Um, and so that is a part of my life that I wish that I wish I had back. I don't know that I wish I kept up, and I'm I'm sure I need to find a way to get more of that into my life. But yeah, I absolutely love juggling. I love the juggling.
At the height of your juggling abilities, what were you capable of doing?
So I tended to not really go for numbers juggling. So in terms of numbers, it's like I could do four. I was working on five. But what I really liked was the huge variety of tricks that you could do with three. And so that is what I spent a lot of time working on. And even from a performance standpoint, because I did perform, I did corporate events and whatnot, and busking on the street. Uh, but there comes a point when it's like the audience doesn't really know. So learning to juggle three is, let's say it's like a 3 out of 10, and learning to juggle, four is maybe like an 8 out of 10, and learning to juggle five is like a 26 out of 10. Like it is way way harder to learn to juggle five than that step from three to four. But the audience doesn't care, right? It's like, look at this trick that I have spent like 2 years working on, and they're like, yeah, okay, I guess it's juggling five. I've seen other people doing five, right? Like it doesn't have the same kind of oomph for it. And so at that point, so when you're getting to numbers, you're really just doing it for yourself. And so I was working on five because it was an interesting project. But for me, I really liked all the tricks and sort of the fluid motion and interesting things that you could do with three. It's kind of the like creativity through constraints, right? My constraint is that I only have three balls, but so what? There's a lot you can do when only juggling three.
Man, I never thought about it that way because I got pretty good with three where I could grab a ball in the air. I could never go behind my back. My shoulders didn't really work really well. I could spin in the air. I could slow it down, speed it up. But I always felt like it wasn't enough. Like if I didn't get to four or five, I just really couldn't consider myself a juggler. You're making me rethink the entire thing.
Well, and one of the things, like I hung out with the Toronto jugglers, right? And we would meet every Tuesday. And so you're around a whole bunch of jugglers, and there are some people who are jugglers, like that is their job. And there are some people who work in an office all day and come and just juggle. And so you sort of learn about all the different areas of juggling and other people's approaches to juggling, right? I wasn't just in my bedroom, working on it because I picked up a book. It was really part of the juggling community uh, that I was at there. Actually, if you want to know how I got into this, how into the computer stuff, it's because of people who were at the Toronto Jugglers Club. Um, I think
Tell
probably
the
talking
story,
to them.
dude. Tell the story.
No, well, I mean, it would have been, I like programming, and they're like, well, you should try out this Linux thing. Um, and sort of, well, I'm interested in this. Well, here's a book. So, I mean, it's a combination of me getting books from the library and talking to them and getting stuff back. So,
All right, let's get you ready to go to university. What are you thinking about university wise? Was there a specific school and study, or you were unsure?
so obviously, being smart in math and physics, which really is just math, um, at least at the high school level. Uh, everybody was saying, "Oh, like you're going to go and be an engineer." That was kind of like the default occupation that I was being given. And I think the people that I knew that were in university at the time were also engineers. And I remember talking with somebody from the Toronto Jugglers Club, and actually, this is Gregor McNish, and uh, he uh, he was the person I think that helped me over the phone install Linux. Oh, those so many years ago. And he was like, well, like look at. It's like I know everybody's telling you to be an engineer, but look at the people who are doing what you want to do and see what their degrees are in. Uh, and and I remember I think probably Brian Kernan, who I looked at his stuff and he's like, oh, he has like a computer science degree. And if I love math so much, maybe I should do something that is like more like on the math and computer science stuff because I'm reading all this AK Dudney stuff, and he's like a math computer science prof. Like it's not the engineering side of things; it's the more theoretical side of things. So I'm going to go and do that. And so even though I sort of everybody was telling me, oh, like you are going to be an engineer. I ended up applying to a bunch of computer science programs and got into a bunch of them and ended up going to Waterloo for my degree.
So let me ask you this question. So, at the time, at least, going into computer science wasn't going to be an engineering degree, like because it wasn't traditionally mechanical or double E or ceramic. Is that kind of what the?
Well, so at Waterloo, the computer science department is or was part of the math faculty. And like the computer engineering was like part of the engineering faculty. Like that was a different set of things with a different set of topics and a different focus. Um,
You were
and
going to end
I
up with
think
a
probably
math degree.
yes. And so actually, my the piece of paper that I have in my parents' basement somewhere actually says like bachelor's of mathematics, like honors computer science. I think Waterloo probably now has like actually a like computer science TM degree. I don't know, but again, my undergrad was part of the math faculty, and I'm sure that affected like how I view programming. Again, with everything that I was reading, is like, oh, like this is all just math, but it's like math on a computer. Um, and then sort of getting into the heavy math stuff, and encouraging me that like I can read these academic computer science papers and research papers, and then when I'm off in the workforce, reading papers, it's like, oh yes, like I know how to do this because I did this kind of thing back when I was at university.
Well, I want to interrupt you for a second. Was college as easy as high school was? Was there something there that like challenged you, and you were just like, I can't do
Oh
this?
yes. Absolutely. I mean, this I think is what happens to I'm going to say the traditionally gifted kids. Like they breeze through high school and then bam, they hit a wall in university, and that 100% happened to me. All of us. I mean, there were some courses that were easy and some courses that were hard. But it's one of those things where you have like sort of like all the smart math and computer science kids from all over Canada show up at Waterloo. And the triangle, that used to be like the top 1% is like now your entire class. And it's like, you're in there, you might be at the bottom there, but you're still there. And so it's really easy to say, oh, like, yeah, those people are in like the smart math classes, and I'm just in like the dumb math class. And sort of like totally skewing off your entire perception of how smart you actually are to like have gotten there in the first place. But it was hard. It was hard. I had to work. Probably for like the first time in my life, I had to work at an academic subject, and it was tricky. And I know that I had some fellow students who did not take hitting that wall well, and dropped out of the computer science program because all of a sudden they couldn't take the hit to the ego that is effectively being shown that you're not smart and everything will not come super easily to you.
Do you remember the moment where you had that wake up call? Was it like after your first day of classes? Was it a weekend? Was it that first bad grade? Like, do you kind of remember having that moment when you're like, oh my God, this is real?
I mean, there were definitely things, in first year. I mean, I think the first computer science course I took was still really easy because it was, just introduction to kind of programming and stuff. Um, it may have been one of the it's probably one of the Calc 2, so that would have been like starting to deal with like all the integration stuff. All of a sudden, like, okay, now I have to like cram all this stuff into my brain. Or maybe one of the physics courses that I took, where all of a sudden it wasn't just like regurgitating formulas; it was having to do a little bit more thinking. And I remember, yeah. So those would have been courses first year. I guess Calc would have been. So I guess Calc 2 would have been second term, and probably the physics course would have also been like second term. So it's like the second half of my first year um, at university. That it was really a shock. I was like, oh, I really have to work. It's not just enough to write out the answers because they come easily. But
I imagine that some people would get excited about that. I would almost imagine that you would be a little excited about that. Like, finally, I have something that is challenging me.
yeah, I loved it. It was hard, but I loved it. Uh, it's and to the extent that like I graduated, I considered going off and doing grad work. Um, and even now, it's like, man, I miss university. But it's probably I'm just like looking back through rose tinted glasses. Because it was hard, but I loved it, right? And I certainly left university thinking like I loved it. That was amazing.
So I'm guessing that you graduated university around 2002,
2003. So
2003. Okay.
the Waterloo Computer Science Department, so they actually have a co-op program. So it's a 5 year degree, or rather, let me rephrase that. It's a 4 year degree. It takes 5 years, but you're alternating school, like sort of like on campus work with basically like internships, like paid internships at sort of various companies. And so at the end of the 5 years, you have a 4 year degree and 2 years of work experience.
Wow, on your
Um,
resume.
on your resume. And so like I did a ton of stuff. I worked at Certicom, which was the crypto company that was bought by BlackBerry, um, and that did all like their ECC elliptic curve cryptography patents. I did some stuff there. I worked at the Bank of Montreal in their like fraud department, right? I was a sysadmin, at a couple of small startups, and so you just have this huge range of experiences, and you say, well, what is it that I like doing? What size company do I like working on? And of course, you're getting paid. And so you sort of, you end your 4 month stint and you end up back at university and you're like, hey, I've just paid for my next 4 months of university. Um,
Which of those internships did you enjoy the most? Was it the heavier crypto algorithms, elliptical curve stuff? I find the fraud stuff interesting just because you can't imagine what people will do. I did a little fraud detection.
Yeah, so I think the one that I enjoyed the most was probably my time at Certicom. And I think there were a couple of reasons. Like it wasn't a tiny company and it wasn't a huge company. It was kind of like a middle-sized company. Um, and I did a couple of like really interesting projects for them. I remember I think I moved them from trying to think. This must have been a move from RCS to CVS. So I did all the scripting and automation stuff for that and cleaned up all their make files to not be so horrendously ugly. And I think one of my favorite projects that I did, for one of the things that you have to do for your co-op program, is you have to write a work report, sort of, basically like a little engineering document. What it's kind of like what I did in my summer vacation, but like sort of going through like a specific project that you worked on, and sort of like writing like a work report, like you would actually if you were in an office writing a report on something you did. And one of the things that I did for Certicom was so again, this is going back many years now. So they had a crypto library that ran on embedded devices. And one of the things that you could do with the IDE that they were using, which was MetroWorks Code Warrior, is if you had a Palm Pilot, remember those, plugged into your computer, then you could tell MetroWorks Code Warrior to like upload the current binary that you're working on, and run it, and then bring out the results, right? So you could not run it in a simulator, but run like your code on an actual device. And I hooked up like a serial monitor and reverse engineered this protocol that MetroWorks Code Warrior was using to talk to the Palm Pilot so that we could take nightly build binaries and upload them to devices and run them overnight and get the results back in the morning. And so I wrote a report on that. And that was so much fun, like reverse engineering this binary protocol going across the wire, printouts of hex dumps going, okay, so this I think is my length field, and so it's going to be this, and so this is probably like, here's the file, and here's the name, and doing all that. And that was so much fun.
Do you remember the first time you got it working, even Happy Path? You must have been just dancing.
Not specifically, but yes, I'm sure I was. This would have been 2000. I think I was doing this, maybe some 2001, I think.
So when you graduate in 2003, are you thinking now I want to get into industry and maybe go back and work at that company? Are you thinking postgraduate, like graduate work?
Yeah, I had vague ideas of maybe I'll do some grad work in like crypto or security or something. But my grades weren't good enough. But it was one of those like, this might be fun. So I don't know if you ever saw the Handbook of Applied Cryptography. It was like a big green reference manual for crypto stuff. Anyways, at university, I had 2 of the 3 co-authors as professors. For my various courses. And I was like, man, maybe I should go to Ottawa and do grad work with Van Oorschot, who would have been the 3rd one. And then I can get his signature on my copy as well. But no, I was like, oh no, I'll find a job. And actually ended up working at a startup in Montreal. And I think that was an entertaining thing. So it was a startup, basically entirely populated with Waterloo grads, and we kept getting in these co-op students as well. And so our entire release schedule was basically like, we were still thinking in these like Waterloo terms, because you would get a student in, you'd have 3 months, or I guess 4 months of their time to like get them to do development, and then you'd have a release, but when they went back to school.
But what was the problem? What was the problem this startup was trying to solve?
So the product was, sorry, I guess, so the company name was Nitty, Net Integration Technologies Inc. And they were basically an autonomous Linux server for small businesses. So it's like, I want to have a mail server and a print server and a file server with backups, but I don't actually, but I have like 5 employees, so I don't want to have a sysadmin on call. And so you had this little expert system that would sort of run on this basically embedded Linux machine that ran a couple little web drop-downy things, and then would sort of detect stuff. And that was cool. I think Nitty was eventually bought by IBM.
It's almost like they wanted the cloud, but it wasn't there yet. So just give me an appliance for these things.
Yeah, that's entirely what it was. yeah. And actually, um, the so a bunch of the people that used to work at Nitty are now Tailscale founders. So there you go.
There you go.
So I know a bunch of those people. Uh, and yeah, and so I worked for them for a little bit, and then I think so. Nitty had this weird split where like all the engineering was in Montreal, and all like sales and tech support and sort of bureaucracy administration was in Toronto. And they wanted to shut down the Montreal engineering office, um, and offered to move us all back to Markham, which is like a small suburb of Toronto. Uh, I think most of us said no, because why would I want to move from like this awesome city, which is Montreal, to this small suburb of Toronto? Um, and so, got another job in Montreal doing not particularly interesting work. Check my LinkedIn if you really care about it. But then I got an email from a friend of mine, or rather, a friend of my brother's, who, when I was like an annoying teenager, told him, "Hey, you should check out this Linux thing." Um, and he said, "Hey, Damien, do you want to move to Amsterdam?" And I said, well, sure, why not? Because I think if I was watching the movie of my life, I would want to watch the version in which the hero said, like, sure, yeah, I'll go do that, because that sounds like an adventure, rather than watching the version where she said, no, I think I'll stay home. That sounds like too much of an adventure. Um, and so flew to Amsterdam.
What year was that? Like 2005,
So that would no, so that would
2006?
have been 2009. I flew in September because the cover story was I was taking my wife to Amsterdam as an anniversary present. Because you have to cover for these things when you're flying around for job interviews and you have a job.
But that's what you're telling the border patrol.
Yeah.
Yeah,
Well,
it's a
no, I'm not.
vacation.
No, no, I'm not even talking about the border patrol. I'm talking about my coworkers, right? Like, hey, why are you flying to Amsterdam for like a day, right?
Oh,
And now, to be fair, I did the same screw up when I interviewed at Fastly. Like I flew, from Amsterdam, to San Francisco, and took a picture of my breakfast, a coffee and a bagel, whatever, like a croissant, and got a DM from one of my coworkers saying like, your tweet is geotagged California, and I'm like, oh man.
oh
Um,
shit.
so it's like, but I mean, to be fair, it's like there are only a couple of reasons that someone in my position is likely to fly to California for like 48 hours. But so that was, yeah. Anyway, so yeah, so flew to Amsterdam, got hired, was there for a bit.
The Amsterdam, the first job you took in Amsterdam, was that booking?
That was booking. That's I was in Amsterdam for booking. My visa was tied to me being employed at booking. Um,
But what were you doing for them? Because I have a vague memory that it wasn't as technical as algorithm work for some reason. So what did they originally hire you? How long were you at booking? You were there for like,
I was at booking for 7 years, and given the growth that booking was going through, we went from I think about I think the IT department was, I think, 65 people, about half of which were devs when I started, and about 1,200 people worldwide. And when I left, the engineering department was 1,500 people, about half of which were devs, and 15,000 people worldwide. And so that was like a crazy amount of growth while I was there. Not only for the company, but obviously not only for like the business, but also like the business, like in terms of Euroscience, that we were doing.
what did you get hired for?
I was working on infrastructure, right? Basically writing Perl infrastructure for their stuff.
That sounded good to you at the time? What was exciting about switching to infrastructure and writing Perl?
When I started running Linux, I started doing a little playing around with writing little scripts in Perl. But I'm like, I don't really like this language, but it's a language, whatever. And throughout my co-op positions, um, like I did some of the sysadmin ones, and those ended up being like writing stuff in Perl. And I'm like, well, okay, fine. I guess I know Perl, but this is not my favorite language. And after I graduated, I went to NITI, and again, I was basically hired, to work on this autonomic system, right? So it's basically C++ kind of stuff, and like Linux shell scripting, and for all that, and sort of kernel internals. Um, And like within a couple months that we were there was basically a hackathon to figure out a new way to write testing frameworks so that we could test nightly builds like on real actual hardware. And the team that I was on, I don't remember if we won or if another team won, but at the end of that, I was then put on taking this hackathon thing and rewriting it and getting it into like productions that we had a thing. And that was in Perl. And I'm like, well, that kind of sucks. I guess this isn't my favorite programming language, but I will do this because it is an interesting problem. And then the company that I was at after I was at Nitty, again, that was a Perl shop. And then we ended up doing a rewrite of the billing system, and that was in Java. And I'm like, yay, I get to do Java because I'm not doing Perl anymore. And when I got the email from my brother's friend in Amsterdam, he's like, by the way, it's in Perl. And I'm like, you've got to be kidding me. It was the language I could not get away from. But I took it because it was an adventure in Amsterdam, right? They were I was gonna go to Amsterdam and work at this company. That is why I did it. Because hey, it's an adventure, right?
I don't feel like the job was technical enough for you. So is this where kind of you find Go? I want to know about when Go hits your radar screen, because you were doing a lot of algorithmic stuff, producing a lot of algorithmic stuff in Go, like stuff beyond my brain. And now I'm wondering if that's how you were kind of keeping yourself, I don't know, sharp, occupied, or interested.
At scale, even dumb problems are hard. And booking absolutely had that problem, as it were. There was so much traffic, there was so much data, there was so much of everything that even the dumb problems were really hard to solve. And so a lot of that work of like, well, how do we solve this was, like either things that I was being tasked to solve, or things that like other teams that I was sort of, chatting with were tasked to solve. And so a lot of that was me diving into the research. Well, how do we solve this? What is the research out there for streaming quantile support? Just like all these kinds of things. And so I think I ended up finding, and so a lot of that work came from me just, a combination of what are interesting problems that booking has, and what is the research around them, and then can I understand them enough to implement them so that I can answer questions about them when I then go back and talk to the teams and say, here, like I found a thing that solves your problem. And for me, I mean, I just, so yeah, Go was around this time, I think 2013, I think, was my first G plus note about playing with Go. Yeah, it was one of those, like, so a lot of my work sort of in university, and part of that, like I was writing everything in C. And at one point, I think after I graduated, I was like, I was never really happy with the compiler that I wrote during fourth year. And so I'm like, I'm going to write another compiler, just so I like really sort of understand. And then it's not kind of like this, dumb hacky thing put together for this coursework. And I remember I started, I have to write my lecture, and I have to write my symbol table, and so I need like another hash table, and so I need another linked list. And I was like, you've got to be kidding me! Like, I've done this so many times. I'm not doing this anymore. And so that's when I picked up Python, and I'm like, this is fantastic. And so I basically learned Python writing a Pascal compiler in it. And so for a long time, my joke was, well, I've only written one program in Python, and it's a Pascal compiler. And so I always had this issue. It's like, well, I want to write this. I have an idea for an algorithm. I have an idea for a thing I want to write. And having to basically mentally decide, well, am I going to sort of prototype this in Python, or I'm going to do it in C? Like, which one of these am I going to choose for this project that I want to write? And I remember discovering Go, and I'm like, well, that solves that problem, right? Like, I have all of the niceties of Python with everything that I want from C, and it just fit exactly where it was I wanted to be writing code. And I was like, that's it, I'm done. I've now found the language that fits exactly with that is exactly what I want. So I kept doing Go because it was exactly the level of abstraction that I was happy with, and I could go both up and down the tower of abstractions.
Wow. Okay, so I like the idea that, Bill, eventually at scale, even mundane problems become interesting. And you're solving you're it's one of the few times that I'd feel comfortable saying that you're dealing with Google level problems. Right? I say you're not Google. You don't have right. You don't have to worry about these problems, but you have to worry about these problems now. Um, Talk about as you're learning more Go for the things that you want to work on, and you're seeing the problems that are happening at Booking, how you begin to try to say, hey, you know what, Go's a better fit for this than what we're doing in Perl. Like, talk a little bit about maybe the first time, if you can, like, you have this idea that, if we did this in Go, it's going to be much better. And not because I want to promote Go, I want to kind of think about the engineering track you took there.
I will say it was not easy. I will say, and probably for a number of reasons. One of which is probably I think just the engineering culture at Booking. It had a very specific culture that I think made it difficult to introduce new technologies. Um, some of it was probably my approach. I probably was not the most politic of at the time. I would probably do a better job now. Yeah, I think it was just like a GeoIP lookup service that was so basically integrating with MaxMind and all of our other internal logic around of stuff, and uh, basically the guy that was actually writing it was sat next to me, um, and I'm like, you know what, I'm just going to write this in Go, and so basically have like a parallel implementation um, for when slash if his falls over. And that was nothing to say. I mean, and he was a fantastic developer, so it was not saying like, haha, I'm going to do this because I'm better than you. I'm like, but like, how hard is this? What does the code actually look like for a production service? That we would want to deploy at Booking. What does the code complexity look like? What does the request timings look like? What infrastructure do I have to write to make it easy to deploy something in Go at Booking? And some of that was, well, we want to connect to our databases. Well, we have a custom config file format. Well, I have to write something that can parse our custom config file format, right? We have, standard health checks. Okay, so what does the implementation of a standard health check package look like? How can I make what I'm doing in Go look as friendly to these devs that are custom not only to Perl code but to Booking Perl code and all of the conventions and niceties that they have, and I have to start building some of those in Go. And so a lot of the initial time was I'd have a hackathon, or I'd have some free time, or I'd have some time at home, and just like starting to build up these set of packages so that we could so that when the time came, I didn't have to say, let's use Go. Okay, and now I have to spend, like 3 months building out all this infrastructure. I would say, okay, let's use Go. And look, I have spent 3 months of my own time already building out all this infrastructure.
I didn't even think about that. I never thought about all of the little packages for logging, even metric, like just so that service plugs in as if it was written in Perl. Like, yeah, of course, I don't know why I didn't think about that, but I can imagine the amount of tooling and libraries they had that everybody just relied on. You have to rebuild all that. I mean, it's a big system.
I did have to rebuild all of it. And to be fair, that was one of the arguments against switching to Go is like, like we have all of these things, right? Like all of these things, Perl developers expect, our systems expect. And to be fair, like that is a really good argument for not rewriting everything in Go. Is you lose all of that, all of those little bits of things that people are accustomed to. But I started small by doing that and finding small services, and indeed it turned out that at a certain level of requests, the Perl one was not holding up, and I was able to say, hey, look what I have just sitting here. And we did the, side by side tests and we deployed it. And I was like, great. Like, that's great. Like now we have our first one in production.
That's wild, man. That's amazing. That's awesome. That's a great story. I mean, tremendous amount of effort and work and unknowns there. But at the end of the day, were they happy when that started solving the problem?
I mean, it's one of those, like, are they happy? It's like, well, they're happy I've solved the problem. They're annoyed that I did it in Go, right? But the alternative is, well, like the Perl web serving stack that we're having, like that we have, just is not able to serve requests fast enough. So we could just have like a ton more servers, or we could replace like all of these servers with like two Go servers, like one primary, one backup. Um, you know, uh, and so at some point they're like, okay, like it's like you win. It was a begrudging win. And I think the the service that I built that I think really changed minds a little bit more was not actually a piece of infrastructure that was written in Perl that Booking was responsible for. It was the reimplementation of Graphite that I did. Um, and probably my last 3 years, last three and a half, 2 years, whatever, in that range at Booking, I was working on re-implementing all of Graphite in Go, because we had an enormous Graphite stack, and the Python implementation was falling over. And we had an idea for a hackathon. We were going to try and basically write a reverse proxy that could, fan out requests to a bunch of different Graphite servers. Um, and, sort of end of the day hackathon, we had a proof of concept written in Python, um, but it couldn't actually handle the load. And I went home Friday and implemented a bunch of patches to a pickle library, which is the Python serialization format. So I fixed up a serialization format library and basically re-implemented this proxy sort of over the weekend, and came in Monday and said, like, look what I have, and we deploy them this is exactly what we need. And then from there, just continuing to add more and more features to this replacement Graphite stack. And Booking is still using that stack. And I think there, just like the benefits was so obvious that they couldn't say no. Um, and and so a lot of my work again on interesting algorithmic problems were like, yes, even the mundane problems are hard at scale, and we definitely had scale for our Graphite cluster. And so a lot of my work and research was like, how do I fix this problem that I'm having?
So what happens in 16 that you decide now you are
That's
going to change?
2017.
17, sorry, 17, 17.
I think I wanted to move on. I loved being in Amsterdam. I really liked working at Booking. I felt, it's like the graphite stuff. It was kind of secondary, right? It was not, it was something that they needed. But they would have been happier if it was not something they needed, you know. And so I felt that the engineering culture was not changing in directions that I felt it ought to be changing. I felt that, my position as a Go developer, I was kind of stalled because I was not working on like something important, like from the hotel booking side of things. I was looking on this like annoying piece of infrastructure that was written in Go that they kind of had to have me around for. Um, and so I was like, I think it is time for me to move on, and move to a company where Go, where they're like, "Yay, Go! That is what we want," as opposed to, "Well, I guess if you have to write this thing in Go, I guess we'll let you," you know. Um, and so I landed at Fastly.
You could have went anywhere in 2017. You had enough of a presence in the Go community and the quality of the work that you were doing. I think you even gave that keynote by 17, right? At Go for Con UK. I mean, you could have went anywhere. So I'm kind of curious, a couple things. I imagine you did your search a little bit underground, and maybe kind of share why and you're still at Fastly today, right? So,
I'm still at
and
Fastly
you,
today.
yeah, right. I mean, you find a place that you're happy with, you don't change. So I'm kind of curious why Fastly when you could have worked literally anywhere you wanted at that time, from a Go shop perspective.
Um, I mean, I think um, they had interesting problems. I mean, I think much like booking, they had the at scale, even the mundane problems are hard, and obviously they have a lot of hard problems that need to be solved at scale. I really liked the people that I interviewed with, and I liked the engineering culture that I was, I guess, learning about. Um, and I knew a bunch of people that were there, and they all seemed like nice people who were still happy to be at Fastly, uh, and I think also, I was able to be remote, which was something else that was important because I really didn't feel like moving back to the United States at that point, or rather moving to the United States. And so I think they just Fastly was a was a reasonable place. It good engineering culture, hard problems. Definitely a lot of work in Go, but a lot of work obviously in C. For everything that they were doing, and just a lot of interesting problems. There you go. And so I said, sure.
But I think the remote is a good point because there wasn't a that was still really new back in
It was
17.
really
Not a
new.
lot of companies
Yeah,
were
yeah.
doing remote, and that was a novelty for sure, at least back then. You move the family closer to the family. That's awesome. You start this job, you get to work on Go full time. You're working on really, I guess, in an essence, from what we can talk about, again, large scaling issues with requests and handling that stuff.
Well, I mean, so
Uh,
I can talk about what I was working on for the first four
yeah,
years
yeah,
that I
yeah,
was at
yeah,
Fastly.
yeah. Do
Basically
that.
scaling out our TLS infrastructure. Right. So you can imagine if you're a CDN and all of your customers have a TLS certificate, then when they come to you, you have to present a TLS certificate for that HTTPS website. And if you have, one customer, then you have one certificate, and that's not really a problem. But Fastly has slightly more than one customer, therefore we have slightly more than one certificate, and all of a sudden it becomes a mundane problem that is very difficult at scale. And so I worked on the distributed system that kept all of that up to date. Um, and that's a hard problem. And there were a lot of really interesting optimization opportunities that were there that presented themselves, both from a sort of like micro optimization level, but also from a distributed systems sort of like optimization level in terms of minimizing communication back and forth with all the different things, and minimizing storage on disk, and minimizing stuff in memory, and all of that. And so I did that for 4 years.
I imagine cert management is a nightmare too. At some point, it's not just one. Is it just one certificate? You got to manage one for every customer at that point too, right? Like, there's no Let's Encrypt at this point. There's no APIs for that at this point, right?
I'm going to defer these questions
Okay, that's
and
fair.
say
That's fair.
probably
That's
can't.
fair. That's
It'll just
fair.
be easier if I don't talk about this stuff.
Yeah, yeah,
Uh,
yeah, no, I don't want to talk. Anything you can't talk about, you just say no, Bill. We're not going to talk about that. Um, I am curious though, when the new problems that you're working on now came up, were you excited to jump into TinyGo and Wasm? Was that
so basically, obviously, we have this computed edge product. An internal team was starting to write a proof of concept. Like what would it look like to sort of deploy a service in Go? What do we need in order to allow that? Um, and they were running into reliability issues and bugs in it's like, are these bugs in TinyGo, or are these bugs in our computer edge? Are these like where are these things really lying? And I was known as somebody who was good at Go, and the opportunity came up, and I would say like, yes, like I will switch over and spend some of my time helping this team figure out what is going on with their Go proof of concept. um, and that was, I guess, September of last year. So that's now been a year. And just working on improving TinyGo stability and fixing the bugs that were there, the bugs in the compiler, the bugs in the runtime, um, and then also working on working on the SDKs that our customers will then use to write and deploy TinyGo apps on our computer edge.
So I've been hearing the word WASM for, let's just say, 8 years. And I've heard all the promises. And I feel like it comes up and it goes away and it comes up and it goes away. And maybe I don't work on the tech that can use it, but I just would love 5 minutes of your thoughts on WASM, and is this going to stay? Where is it going to use? Will it be more widespread? Like, are you are you positive on it? Are you negative on it? Maybe just some thoughts around this WASM in general.
Yeah, I mean, to some extent, it is the next, like isolated virtual machine, right? I mean, when we think about, like virtual machines, people are like, like Flash, you have all these problems, you have these things and you just compile them to, like Flash, and then you can run it in the browser. But Flash obviously had lots of issues. And people say, well, like the JVM, all of a sudden, like you write once, you run it everywhere, because it's the JVM. And it turned out that, when you only have one implementation, of a thing that is really closely tied to its source language, which in this case was Java. Like the JVM is not actually a general purpose machine. It is very specifically a Java virtual machine, right? There are instructions in there that are very closely tied to the language that it is expecting to be interpreting. And so it's difficult to like compile an arbitrary program down into JVM. WebAssembly, I think, solves that issue. It is, a more general purpose computer, but was also, or I guess instruction set, but was also, designed with a specification, with a reference implementation, with, like known semantics for all of these things, as a target that can be, I guess, like validated and saying, okay, we're not going to have, like if we validate these things, then we know that we don't have any of these things that are likely to lead to security vulnerabilities, right? Like just from the WASM side, like we can sort of, validate that the code is, like not terrible. And so I think in terms of, sandboxing, Wasm is great. It's sort of, you can take something, you can build it down to Wasm, and you can run it in a secure sandbox that you can like both like trust and not trust, right? You can trust it in the sense that nothing is going to leak out of that sandbox. You don't have to trust the code that's running inside it because you trust the sandbox, right? So I think being able to take, like arbitrary code and run it in that sense is great. And, that's obviously what is happening with a lot of these edge computing products, or people are running Wasm not only in their browser, but they're taking other people's bits of code and logic and running them somewhere, right? Like there are blockchain companies that have Wasms for like smart contracty things, right? It's like, well, and so there are sort of like restrictions in that way, and so it is not. I don't have to come up with my own instruction set. I can use this instruction set, and there are really well written, fast, secure reference implementations, or that we can then plug into our blockchain infrastructure, to run smart contracts without having to come up with our own scripting language. All right, so I think, yeah, I don't see Wasm going away anytime soon. I think there are a lot of people using it for interesting things, just for that level of sandboxiness and security.
Is the WASM VM built into your program, so you just have to run the program and it launches the VM and executes it? Or do these machines have a WASM VM that is kind of started in the background and you attach? How does that work?
Yeah, I mean, you can think of it kind of like the JVM loading like a like .class file, right? So the TinyGo produces like a WASM binary, which is to say it produces a series of WebAssembly bytecode operations, and then that .wasm file is loaded into your WebAssembly interpreter. And in Fastly's case, that interpreter is Wasm time, but there are a bunch of others But we really like Wasm time. So
Okay, I see that. Okay, yeah, I'm still. I want to see it being used more. The idea of it running in the browser kind of seemed with all this promise, but I don't see it being used very much in the browser. I guess I'm seeing it more on these tiny devices right now than I am kind of anywhere else. So maybe that's where it ends up really living at the end of the day. I don't know. I don't know. What do you see the future as? You think this is going to become more and more? This is going to be the general purpose machine at the end of the day. We're all going to just be running Wasm programs.
eh, you know, I think until the next one comes along, I mean, I think having WebAssembly as a compilation target, um, means that you are really no longer limited to sort of like JavaScript, because you can now compile things very efficiently down to WebAssembly, and you have very fast interpreters for WebAssembly, and so you can kind of start, and so you're not tied into that JavaScript kind of ecosystem. Um, and so I think people are certainly building large scale web applications, uh, and not having to use JavaScript. Um, and they can build something else, and the WebAssembly interpreter in the compiler, or sorry, in your browser is fast. Um, and I think for all of the like edge computing, running untrusted code stuff that has a little bit of logic, all of a sudden it doesn't have to be like a custom scripting language with your custom interpreter. You can say just give us any kind of WebAssembly in whatever language you want, and we will run it safely and securely on our systems, and you get to choose your language, and we don't care what you write it in because we trust our WebAssembly sandbox.
And what I love now too is you're technically working on open source now, right? I mean, you're
I
working
am
and
now technically
contributing
working on open
to
source. Yeah.
TinyGo. So I think that's really brilliant for that tech in the community. And maybe in another year or two, we get to get you back on stage to talk about some of the cool stuff you're doing with TinyGo and Wasm, dropping a seed.
Well, I mean, like I've had so much fun working on the TinyGo stuff. It's one of those things, like, I don't want to say it's been like an endless source of bugs. It's been an endless source of like interesting things to hunt down. I think it was originally started basically for like blinking LEDs on an Arduino. And because it used the LLVM backend, we sort of got the WebAssembly backend for free. And but all of a sudden, like you you end up finding a large source of bugs when you take a piece of software and start using it in a slightly different way. And I think that the slightly different way that TinyGo has all of a sudden been being used is, I now no longer want to write, like a 20-line program that reads from this I/O pin and blinks this LED or sends, or runs this motor kind of thing. But like large applications that are trying to use like the full Go standard library and arbitrary imports. And so like it's not surprising that this compiler that sort of had this one initial goal, when you try and move it into this much larger goal, is going to encounter issues. And so that has been a lot of my work, just like taking arbitrary programs and running them and finding the bugs and then fixing those bugs. And that's just been a lot of fun. Get to fix garbage collector issues and
I mean, I'm not a compiler person by any means, but basically you have to, your job ends at what, the object code, and then that's passed over to LLVM to finish the remaining work. Is that like kind of where your bugs?
yeah, I mean, we've certainly discovered issues in LLVM as well that we have had to work around. Um, and we have discovered bugs in how we interact with LLVM. And so it's like LLVM is doing exactly what we told it to do. We just told it to do the wrong thing. Um, but I mean, I think for the most part, uh, that stuff has all been ironed out and was ironed out fairly quickly. Now it's really stuff around um, the runtime and reflection support and a couple of other optimization things that would be nice to have. But yeah, I think TinyGo stability has come a long way in the past year, 18 months. And and I'm still enjoying working on it. I've been reading. See, so this is the thing, right? I'm thinking about like how can I improve the garbage collector in TinyGo, and so I've been reading papers about like garbage collection strategies for embedded devices, right? Well, that's kind of like an interesting thing, to read about.
That's awesome. To work on that kind of stuff is right. I think it's right up your alley, and you're the right person to be working on that stuff. That's awesome. No, yeah, that's exciting. All right. Well, unfortunately, we are out of time, and I had no idea you were working on that stuff before we started talking. So, one, I'm going to yell at Ron Evans, if you're listening, Ron, for not telling me how involved you were. But I think it's really good for everyone that you are. So, man, kudos, man. That's cool stuff.
Well, thank you very
If
much.
if anybody wanted to reach out to you after listening to the show, what's the best way somebody can just kind of ping you?
Probably the Twitters, Damian Gryski, and due to the pandemic, haven't had my haircut, so I actually look much more like my avatar than I have in a while. The glasses, the goatee, the ponytail.
Nice. All right, we'll make sure we get that in the show notes. So, thank you again for spending all this time and sharing everything that you could. So, this is the Ardan Labs podcast with myself, Bill Kennedy, and Damian Gryski signing off and hoping to see everybody again real soon.